Okay, matching the system characteristics to your stuff. So of course, if you do it right, then you can hope to get pretty fast turnaround because the jobs that you've got run best on the systems that are suited for that. From our point of view, of course, this is efficient use of resources. We've got a lot of users using these systems, and that scheduler has to do quite a lot of work trying to fit the jobs in to the available cores and the available nodes and the available RAM. So we really emphasize the idea that it's good to choose the right system. For instance, your software, there in that little table down underneath, what kind of software you've got, and then what kind of system will we fit. I've got some more details. I should note that in most of these slides I have a link to what we term our quick start guides. And these quick start guides have all the details. So in fact, a lot of this talk is a slide that gives an overview and then has a link to the quick start guide and the right place to go. So I'd really recommend having a look at this. And there is a new user guide, which is really worthwhile having a pretty careful read through before you get started. Right, so the software. We got a lot of folks using off-the-shelf software. So they have specific characteristics. The analysts, the support analysts, know a lot about what's installed on the systems and what they do. So if you're using something like Gaussian or GROMACS or OpenFOAM or whatever, really good idea to ask the analysts to have a look and see what you're trying to do. I think actually that every site should have an analyst in the room. While I'm thinking about that, you guys want to hold up your hands if you're in the room? Yeah, so you can look around and see, and you certainly can talk to the analysts after this talk. Memory requirements are always critical. So how much memory are you going to use? How much RAM? Is it distributed? Is it shared? What can you do with it? And does it fit in the machines? Lots of things there that one wants to ask. Parallelization, of course, yeah, okay, it's a cluster. Are you going to use that distributed model? Are you really going to start distributing across multiple nodes and try to run big simulations? Yeah, great stuff, but that means that you don't want to run on some of our machines with slower interconnects, for instance. The other one I want to note at the end here is this business about research program characteristics. We do have a very wide range of users. There are users who really are investigating a parameter space. So you might run 1,000 jobs, trying to run them as fast as you can so you can get the results out and maybe do some optimization, something on that line. Great, but in that case, you're probably going to run as much as you can on single cores, and single cores or single nodes, maybe a few core simulations, and just try to get them all in there and running as quick as you can. Then on the other end of the space are very large jobs. You want to run a great big supernova calculation, and you're going to run 1 million nodes, and you really want to make that big one. You got everything organized, done your tests, etc. In that case, you want a significant proportion of one of our machines, and of course, then we have to kick off all the other users, and the scheduler has to figure out how to do all that. So lots of interesting places, and you might actually be developing code. Your bursts, we've grad students developing code have a habit of going in bursts. They develop a little bit, do some work, write some code, and then they run it a few times to see that it doesn't work, and then they go back and start working a bit more, and then they run it. So they're kind of bursty. Here's our sort of quick table. It really comes from the quick start guides, and gives you at least some idea of the diversity of machines you've got. For what we term small memory serial, so those are not very parallel jobs. They're going to run maybe on, certainly on one node, maybe on just one core, and they don't use much memory, and probably those are the ones where you're running a whole bunch of them. And our machines are labeled things like Hermes, Bugaboo, Jasper, and Orsinus. You can think of those, that's hermes.westgrid.ca and bugaboo.westgrid.ca. And these machines exist at various places in the WestGrid network. So we have a number of machines there, each one with specific characteristics. If you need to know more about these machines, again, you go to the website, www.westgrid.ca, and there you'll find the technical specifications for each of these machines. Shared memory, Breezy and Hungabee. Hungabee is a special purpose machine that has extremely large memory and kind of looks like one great big shared memory system. And that, if you need something like that, requires you to specially apply for it. OpenMP is the standard package which allows you to write shared memory codes. Distributed memory, MPI is again the other package that allows you to send messages back and forth. The M in this case is message, so it stands for the message passing interface. And we have a number of machines that are capable of doing MPI. So essentially, these are standard machine I indicated with those InfiniBand interconnects, so you can start running code that will run back and forth between different nodes. And we have some machines which are really good. There's kind of small memory, but there's lots of nodes, and you can distribute out. And then we have something like Grex, which has quite a large memory, 4 gigabytes per core, and can be used for in those cases where you need more. So you can start to see, I think, already that machines have very different characteristics, how they work, approaches. And another thing I'll just note is that each of these has a different software suite as well. So that's kind of interesting. They have different software packages installed, and one of the things you need to do is to go and have a look and see which one's got the software that you need. We do have some graphics and visualization, or GPU, or one machine, parallel, here at the University of Calgary, has GPUs attached to some of the nodes. So if you need those graphics processors, remember those are kind of very high performance vector processors, but a little tougher to start programming, yeah, we have some of those. Here's one of these special, software. What happened there? Okay. Did the presentation disappear? Can you guys see my presentation? Or is it? Did everybody?
If you could reattempt to send your presentation to open the system, please. We don't have anything reading on the bridge right now.
There, it appeared. Okay. Yeah, can you see it?
That is looking good. Thank you.
Okay, good. Yeah. Right, GPU, Gaussian. So Gaussian is one of the standard chemistry codes, and an awful lot of folks use Gaussian, and that's sitting on Grex, and we've licensed it. There are other special software, MATLAB, GROMACS, things like that, and I'm just going to point you to the quick start guides and the software guides to see what's going on there. And then finally, I'll note that we do have a very large almost 3.2 petabyte storage system in Saskatchewan, which acts as the central archive and backup site. So that's not a compute site. You can't compute. But if you do produce nifty output, lots of stuff that you want to keep and analyze later, that's the place you start moving it. And that's a sort of fully backed up, very large system. And I'll talk about it in a minute, but there are easy ways, or at least fast ways, of trying to move data over to Silo from the compute systems. So yeah, lots of systems, some special purpose, some general purpose, lots of software. You can work on multiple systems if you want. Nothing to stop you logging on to different systems, but each one will be a little different from each other. So especially if you're working on some different kinds of codes and would prefer to run on different systems. It's hard to choose, there's no doubt. This is one of the standard questions that appears on our help desk and support lists all the time. So down at the bottom there, I recommend really strongly talking to an analyst about your particular requirements and what systems would be best to use. Right, getting into some of the nitty-gritties at this point. So you want to connect to the cluster. how do we do that? Well, we got those login nodes, and each login node runs Linux. In fact, all the nodes run Linux. Linux is the standard for all high-performance computing across the world. So somehow you need to log in to get to the Linux command line. That's just a standard command line terminal. Been around for yonks and yonks. As does everybody else, we use the secure shell, SSH. Linux and Mac both have their own SSH clients built into the operating system. Essentially, you usually open up a window and type SSH. Details are on the website. And unfortunately, Windows is based a lot around Windows, so you almost invariably have to install a little piece of software. But it's an open source, free software. Putty is the one that we recommend. So yeah, you might have to install, if you're on a Windows laptop, Putty, a Putty client, so that you can use SSH to get to the big systems. I'm not going to give you any details. Go to the Quick Start Guide and have a look. Linux itself, yeah, you do have to know a bit of Linux. In fact, maybe a little more. When you submit a job, you have to describe the job. You describe the job through a Linux batch script. And you'll want to do things like copy files, make directories, keep an eye on your output, all that kind of stuff. So it's a good idea to know the basics of Linux. Yeah, I was thinking of actually writing out some Linux commands here and doing some stuff, but yeah, Linux is universal. There are quick starts and tutorials and guides everywhere out there. Our own Quick Start for new users does have a recommendation for a good place to go for a quick tutorial. So you can find everything you want out there. If you're not familiar with Linux, haven't used Linux before, I really recommend going to find one of these simple tutorials, the one recommended, and work through it. A few other things that we've got on pretty much every system. Yeah, there are things like editors and visualization and graphical interfaces. Yeah, Linux has that too. In fact, just as an aside, my laptop is a Linux laptop right here, and all this is through my Linux Windows system. I don't have Windows on it at all. The Linux windowing system is called X Windows. I think X Windows has been around longer than Microsoft Windows, in fact, when I think about it. It's the basic thing that everybody uses. And indeed, SSH, the secure shell that you log in with, knows how to tunnel X Windows commands back to your laptop or to your desktop. Unfortunately, your desktop had better understand those X Windows commands. So again, if you're on Mac OS or a Linux box, no problem. That's what your desktop does use. So, doesn't it? Doesn't the Mac? Oh, I just been told here that Mac doesn't have it built in. You need to install X Quartz. Oh, I didn't know that. Okay. So there's a thing I'm learning. If you're in Mac OS or in Windows, you have to install something that recognizes X Windows. The standard free one for Mac OS is Xming. So you can do that, go and install it, and then you can indeed SSH to one of our systems and use things like the visualization and the graphics editors, those kinds of things. And again, there's a nice link to the details are on the website. Here's one of those little Linuxy things. In Linux, the command you issue is SSH to actually bring up the secure shell connection, but you got to remember to put a -X in there so that SSH knows it's got a tunnel X. One of those little details. And you'll have a username on one of our systems, so a username at and whatever the system is at westgrid.ca. So that could be Grex or Parallel or Orsinus, whichever system you've decided on. So there's the basic approach. You tell it where you want to go, what your username is, and tell it that you want to use X Windows. I hope all of you, I don't know if all of you have got accounts with WestGrid. It's a single sign-on operation where if you've got one account, then you can sign on to almost any machine. Some machines require special permission. If you do need to get an account, then please talk to one of the analysts or just go to the web pages, all the details there. You can apply online. I mentioned back there that we have that silo, brilliant, huge, great backup archival system. How do you get there? Or if you decide you want to copy files from one machine to another one, a classic for that would be if you've made a great big run on something like Bugaboo or Orsinus, but then you want to use GPUs for visualization. So you want to move some data over to Parallel, for instance, to use the GPUs. Whoops, I'm ahead of myself. This is getting from your laptop to our system. So SSH carries data, and there are various versions of SSH, essentially, which can copy files from your laptop back out to the head node, or from the head node back again to your laptop. So many people, I'm included, like to use my laptop with my development environment and my IDEs and my editors for code development and a lot of testing. And when I'm ready, I'll start to move it off to one of the big WestGrid boxes. In that case, you start using things like SCP and SFTP, Secure File Transfer Protocol, to move files around. I've put this one at the end here. Oops, man, gotta be careful. rsync, that's the standard Linux, Unix file synchronization utility, and it knows how to use SSH. So you can start synchronizing directory structures and file structures between your laptop and our big machines. I find that really handy, but it's not trivial to set up. It's quite one of those really nifty, complex Linux things. Feel free to ask about that if you get to the point where you're really going to be doing a lot of stuff on your laptop and you want to make it all look about the same. So lots of beautiful front ends out there to these utilities. So if you're on Microsoft Windows or Mac OS, yeah, you can open up Windows and tell them which machine you're going to and which machines you're coming from. There are some annoying issues with line endings in files, and just note that there's a note on the web pages that sometimes when you bring something over, Linux doesn't know about Windows line endings, and things get a bit garbled. We have a fix for that, so there's a utility that can fix that. Here's the one where I was ahead of myself, inter-site file transfer. In fact, WestGrid has what we term the core network. This is built on Canary's national network of very high-speed optical fiber connecting all of the institutions in Canada. And that's really high speed, multiple fiber strands, multiple wavelengths, the whole works. Therefore, you can start moving things from any WestGrid system to another WestGrid system or to silo really, really quickly. We have therefore some powerful, I've said powerful grid tools. They're usually called grid tools in this sense. And many grids like WestGrid throughout the world use these grid tools. Globus Online is a very nice one where there are centralized places you can start controlling the file transfer. Again, lots of details. Go and see the WestGrid site for those details. Really nice to start running these things if you need them. So you need to get stuff to silo. You can run much, much, much faster than you can run over the standard Ethernet, standard internet. Yeah, some more details. Almost all our machines are running pretty standard Linux stuff. So yeah, you got all the editors. If you're running Emacs or NEdit, I've even put Vi down there. That's classic ancient Linux. Always works, but it never. It's a beast. But NEdit is a nice X-windowed editor, and does all the code highlighting, all that kind of stuff that you're probably used to. Compilers. There, of course, it's critical that WestGrid, any cluster, has a good compiler to compile from C++, Fortran, whatever, and they've got to be really good ones. So, of course, we support the standard GNU compilers, but we also support all the Intel compilers. And the Intel ones generally produce a little faster, a little more efficient code out the other end. And I think almost invariably by default, it's the Intel compilers that you get. They're really nice. Sometimes, though, you need the GNU compilers. And, of course, the GNU ones are free, so you can put it on your laptop as well. Various scripting languages, Python's around. I think Ruby's on pretty much every one of our machines now. I've noticed just in the last few years that Python's become a very standard system. What's going on? Did it work this time? Something keeps, I don't know. Yeah, okay. Anyhow, so Python's good. We got things like that, Python, Ruby. Parallel programming, of course, every cluster is aimed at that. So the big OpenMP and OpenMPI packages are there, plus maybe some other packages. And all the base scientific libraries, the BLAST routines, the LAPACK, all aimed at, those guys are mostly aimed at linear algebra and very efficient, very fast linear algebra. So we all have those, and if possible, we have the tuned ones that come from the vendors, so they work really, really fast. So there's pretty much a whole suite of the standard Linux software. You won't find those, a lot of that stuff defined on the web pages. We just assume they're there. But you will find stuff about the compilers and parallel programming and such. I thought it might be worthwhile talking a little bit about jobs and what we mean by jobs and how they get submitted. So you're on the login node. The login nodes, they're interactive. You can do data management, you can edit code, develop code, and job management is there. I want to note one thing that yeah, you can do some tests on the login nodes, but not much. The login nodes satisfy everybody. We can have lots of users on those login nodes. We certainly don't want you to run hours of jobs on the login nodes. That's what for the big machine are. But you can run small ones. The real work is done on those compute or worker nodes. I don't know if you can see the picture, but down here it says the modern magic and the meaning of life. And that's what you guys do, right? We just give the tools. You guys actually find the meaning. The scheduler tries to submit these jobs to the system as fairly as possible. It's not interactive. These are batch jobs. You create a description of your job and submit that description to the scheduler. And a batch job is defined by a Linux script. So you got to write a Linux script to make it work. You can use an editor to just write the things. The Linux script contains a number of very special purpose commands. They actually look like comments that describe the job, called directives. And they may describe how many cores you want, how long you want the job to run, how much memory you want, those kinds of things, where you want the output, where you want to start it. And that gives the scheduler the information it needs to schedule a job efficiently and well. I should notice that we have some problems with this. It's not trivial, especially when you're starting off, to get these job scripts right. Jobs exceeding those predefined resource limits, well, they're going to get terminated. If you set a wall time of 5 days, and the job runs for 5 days and 10 minutes, it'll fail. This one is the one that worries me most, the incompatible requirements. I don't see a lot of tickets to do with this, but there are some where if you, for instance, say that your job needs 100 gigabytes per core, and we don't have 100 gigabytes per core, your job may just sit in the queue because the scheduler can never find a core with 100 gigabytes. So some little detail-y thing sitting in there. Again, we've got a whole web page there describing that. It's not that long, but worthwhile reading it because it's got lots of the details there. Managing a job, well, you can, of course, submit a job. There's a thing called QSub. Everything starts with Q. You can see if your jobs are running, QStat. You can decide that you screwed up and the job needs to be deleted, so you can delete it. This one's worthwhile, the show start. Especially you got a big job. You want to know if it's going to start in an hour or if it's going to start in 2 weeks. And so start will ask the scheduler when it thinks it can start up your job. Show queue will tell you quite a lot about what's happening with the job and some of the details of the, with the queues and where your jobs are, etc. Here is a little bit of Linux. For instance, QStat, anything in square brackets is optional. If you leave it off, then QStat gives you a pretty default little quick description. If you put -F in before the job ID, That stands for full. Now it gives you all the information that it's got about the job. And Linux does that always. Any of these commands give you all by itself some standard output. And if you want more or specific formats or other things, you have to have these descriptors. For instance, almost every command, if you do show q -- help, you'll get a quick list of what show q does. All of these commands also have on Linux what we term colloquially the man pages. The man pages just stand for manual, and that's a detailed description of the job. I just find that even for experienced guys, we use the man pages all the time. Man q sub, man q stat, and it'll just dump out the whole works. And then the -- help. So there's some help stuff. They're all standard Linux commands. So you can do quite a bit about playing around with your jobs and seeing what they're doing, when they're going to start, how they're going to go. Well, here is a job script, just to give you some idea of what the thing looks like. That first line, that's a standard Linux one. I kind of like this. This is one of these Linuxisms where you tell any file at the beginning what kind of file it is. You can tell if it's a Python file or a Ruby file, in which case Linux knows enough to look at that first line and decide that it should run Ruby on it or run Python on it. In this case, the bash shell is the standard shell. That's the thing you type commands into, and we just use it all the time. These are the directives, TBS directives. That stood for Portable Batch System. Came from back a while ago before the development of more commercial schedulers. So anything that starts with a hash, which actually is a comment, in fact, but this is a special kind, hash PBS is a directive to the scheduler, telling the scheduler something about your job. So you can have a whole bunch of these. In this case, I've just told it that I want only one process, one core. This is not a parallel job that I'm running. Then there are various other ones. This one says that they're standard out and standard in and put them in one place. And there are lots and lots. Have a look at the jobs. The more you can really control your jobs. Some interesting things, you can send email out when your job is completed. That's kind of nice. So if you've got one of those really long jobs, just tell the system to send you email when it's finished. So lots of these PBS directives, they do have to go right at the top. You can't put anything else in here. You can't put Unix commands in between. Then your job. Your job can contain standard Linux, Unix commands, and it'll probably somewhere around the way have the name of your particular code or program, Gaussian, your executable, whatever, and it'll run it. In this case, this is just some trivial stuff. It dumps the date. There's a Unix date command. The Unix echo command just echoes this to standard out. And there's another echo command. And in this case, this peculiar little construction will grab the host name of the system that it's running on. That host name in this case would be the name of the node on which the scheduler has decided to run this job. And submit the job very trivially with qsub hello.pbs. Again, lots of information up on the websites. So you end up doing this, you'd sign a few job scripts. Once you got them set, the nice thing is that probably you can just resubmit them over and over and over again when you're working on things. You may submit all sorts of neat information in there. There are ways of submitting multiple jobs at once, so lots of stuff in there that I've hidden, but it gives you some idea of the approach. So you go on to the login node, you edit, play with your code, get it compiled. Almost invariably, you compile the login code, set up a batch script, qsub, submit the batch script, and wait for your job to finish. When you run qsub, it gives you a number. That number is pretty much all you need, 152.98.317. In this case, I was running on Bugaboo, and I was running in a subdirectory. Then you can do qstat, and it'll tell you that there your job is. And this is the basic, easy output. Doesn't do anything special. -F would get you lots of stuff. Notice that just says it's in the queue. So it's waiting. After a while, while, if you do a few more QStats, it'll suddenly say, there's no job. That means it ran. And in this case, when I look at the output, I notice that there's my job script. The queuing system, or PBS by itself, has just dumped out the output from any errors and the output from standard out. And you'll notice it attaches the job number by default. You can change all that, but therefore you can keep track of which job ran where. And there's the output. Remember I said, what's the date? And Linux told me Thursday, January 9th. I echoed hello world, and I said, echoed, this job is running on, and I gave it the host name S31. So S31 is one of the nodes on the machine called Bugaboo. Okay, basic stuff. Runs, you do it, get the output, there it is. Remember that these directories are all shared between the nodes and the login node. So I don't have to do anything special about getting the data back. You've already written the output, it's there, it's on the shared file system. You just log on to the login node and have a look and find it. These are one of my favorites. I kind of taught computer science and a few bits and pieces and seen folks and worked with grad students, some of my own grad students. And these kind of things, it's so easy to figure you know everything and dive in and write great big scripts right away. And then you spend 80% of your time debugging and 20% actually doing something. You all know the rules. Or maybe even 99% debugging and 1% trying to do something. So I really recommend running some of those small example jobs. There are a number of examples up there in the quick starts. Grab them, run them, do those hello worlds. Make sure you get an idea of what's going on, what kind of information you can get, and then start building up to the kind of scripts that you need and you want. In fact, debugging is one of those ones that's, to me, absolutely critical. Yeah. Again, it's a pet peeve of mine is trying to set up things so debugging works. You can get through it quick. And you know, these are parallel jobs on big machines. A lot of things can go wrong when you write code that doesn't handle the memory right, has some issues. You know, your one thread can run at one point, and the next run, it'll run at a different point. So getting into the habit of I think, early on, getting debugging information in is a really good idea. I've just noticed here that those PBS directives, yeah, you can get a lot of debugging information out of these PBS scripts, and you can start telling it to be really verbose. So go for it, and in particular, all the analysts know everything there is to know about this. So go for it, ask them. They really know, and it's really worthwhile if you're having trouble asking one of those analysts right away. On that line, too, most machines have reserved some nodes for interactive use. So we don't like you running anything big on the login nodes because lots of other people are running there too and doing their work. If you really do need to run decent size, say a couple of hours of test jobs to see what's going on, well, you can reserve a node and work interactively on one of those nodes. You still have to go through the queuing system, so you still have to do QSub and wait for it to give you one of those interactive nodes. But it's really nice to know that those things are there and that you've got some support then for testing, playing, debugging, etc. Never know quite how much to talk about fair share. That's our job scheduling algorithm. How does that scheduler work? Each site schedules their own jobs. They each have a scheduler in front of the cluster. The thing we use is Moab. It's supposed to be fair. In theory, everybody's supposed to be happy when we've got it. In practice, well, limited resources, and sometimes jobs don't run for a long time. Fair share runs targets, and we have targets that are given to the system for all projects. A project, most of the time, is run by a principal investigator, a PI, and he or she has a bunch of grad students or postdocs who are allocated a certain proportion of these targets. The base metric that the scheduler says is that if you sort of add up all the targets, that's 100% of the machine, and we'll attempt to ensure that over some period, some weeks previously, that each of the users get their proportion of the machine, more or less. So if your usage is over the target over that last couple of weeks, then your priority gets decreased, and if your usage is less than the target, then your priority gets increased. Of course, that also depends on where the resources are. Are there nodes available? How many memory nodes? When are jobs going to finish? All that kind of stuff are also in there. But critical is this business. Of course, if you're the only user on a machine, just because your priority is low doesn't mean you're not going to get the machine. Of course, it'll run if the resources are there and the machine is undersubscribed. The resource targets, those targets, they're defined by a resource allocation process. This resource allocation process is a formal review process. Usually principal investigators, PIs, make a proposal to, and in fact this stuff is nationwide. It's a federal operation through Compute Canada, of which WestGrid is part. So you apply to Compute Canada usually in October, and then there's a whole bunch of scientific reviews. I and the analysts and such get to do technical reviews, and then the National Resource Allocation Committee gets together with the scientific reviewers and decides on an equitable allocation. If you don't get a resource allocation or you're new, you do get a default. So anybody can in fact log into the system and they get at least some time. And since it's fair share, you still get some reasonable amount of computing. But if you start using it a lot, then of course come next round, next October, you should apply. A few little details, visualization and graphics. Yeah, we got the GPUs and we've got some nice visualization software. I think Brian Corey, did I hear your voice somewhere back there? He's our visualization coordinator. Yeah, I don't see if he's going to raise his hand or not. But yeah, we've got some support there specifically for visualization, and you can do some nice stuff. Here's a solar wind around the Mercury magnetosphere, and you can start doing some 3D stuff. So yeah, got some visualization, we can help there. And there is some equipment available if you really want to do some flashy 3D stuff and things. Asking for help, just to kind of finish off here a little bit. The support at WestGrid, I keep coming back to that. Really good idea to go right away. You'll get great help at support. In fact, you'll get answers to questions you didn't even ask, because the support guys keep an eye on the systems, and if they see that the jobs are running inefficiently or are suspicious in some way, they may actually call you up right away and say, hey, your job's not doing something, and what are you trying to do? And they'll help you out. If you do mail, please tell us the name of the system. That's the critical one. I don't know how many times you have to go back and say, you know which machine you're working on, but we don't. So add that, the job ID, your WestGrid user ID, email address, something like that. And of course, where the script and job files are, we'd like to have a look at them, and what's going on with the code, if you got it. You can certainly ask questions too, like so I've got this project I want to work on, and what do you think about it? We'll answer those questions too. Well, that's about it. We've gone through really quickly a lot of that. There are the email addresses. Thanks for coming. And any questions? We've got one here in Calgary. Yeah.
I was trying to access my WestGrid account from home.
Yeah.
Laptop. It works fine in the university, but from my home I cannot access. I don't know why.
That's probably a detailed question. Oh, sorry. Right. Yeah. The question was that the gentleman is not able to log on to a WestGrid system from home, while he's able to log in from a WestGrid site. I think that's a detailed question. May have something to do with your configuration at home, your internet connection. And I see that Doug is here.
No restriction from your end.
Shouldn't be. Yeah. So something fish. Yeah. There can be if we see a lot of login attempts which fail. Well, that could be a password cracker trying to do it. So that address might be disabled, but the analyst can check that and see. Yeah. Yeah, another one from here in Calgary.
So we have very large input files.
Right.
And over the structure, you want to background loading water file network, how can you?
So is this a transfer problem? You're just trying to transfer the files?
We just use those input files.
Yeah. So some of the WestGrid sites have large attached shared storage, that's shared storage stuff. So you should be able to get it onto those sites, and shouldn't be a big problem. Oh yeah, the resource allocation process is also a storage allocation process. So you get a default storage amount, and it sounds like you may have some very large files. Yeah. So I don't know if that'll fit in the default. Do you have a? Did you apply for?
No, got that one.
Okay. So yeah. So I think again, those are details that we can certainly work with you, and see what's the right machine to handle that kind of a job. Yeah. Yeah, I think this is actually, I'll just note, just a general comment, that I've noticed that these kind of high-performance computing stuff has moved a bit more from straight compute to also big data. It's happening quite a lot. And the machines that WestGrid has got are 4 years old now. That was sort of before big data. So we have a machine Bugaboo, which can handle big RAM, and we have some big data, big disk systems, but we're not really geared up for the things you think about now as big data. But we're certainly willing to work with those and try to, and we've got some little projects and some approaches. So yeah, we know it's coming, or it is here, I guess. Yeah. Yeah, other questions? Cool. Again, talk to your analysts. They're in the audience. Good. I'm done, and I think
Thanks, Travis.
we're good too.